In April 2018, this posting appeared on the SDR radio mailing list. It's from David GM8XBZ, and he's interested in listening to non-directional beacons. There was an image with this posting, and it looks like this. And you can see the PST, the signal he is asking for on the waterfall, but it cannot be heard with the filter that SDR radio can apply. So I have a copy of this recording that he used while doing this image, and I will play that in Linrad. Now I'm playing that recording in Linrad. There is something wrong with the frequency information. Linrad doesn't know how SDR radio is storing the frequency information, so the signal of interest is at 3.135 megahertz according to Linrad. I have now just set normal processing parameters with a narrow filter. And you can hear PST, but it's hard to see it on the waterfall. If I make the resolution one step smaller, like this, the waterfall runs twice as fast, but resolution isn't very good, and I don't really see better here. And I don't hear from the audio either. So that was not a good idea. I could go the other way. And here is the signal. So I bring it to the center. And now the bandwidth is pretty narrow. I have now set a larger size for the third FFT, so I can apply a much sharper filter. So this filter is something like 17 Hertz or so, and with a fairly good shape factor. And the carriers are just outside the filter. I can apply the coherent detector, that means synchronous AM, like that. And it's easy to hear this ID. But there are other tricks in Linrad. I could increase the filter bandwidth like this, and I skip the coherent detector, and as you can hear, now there are only the strong carriers. But I can apply notch filters. That means click here. Sorry. I have set the bandwidth of about 30 Hertz. So I have this carrier, that carrier, and the signal of interest here, with this keying sidebands here. I was going to introduce notches for the carriers, but I forgot I am now in the time domain for the baseband filter. That's because I had it with very few points on the filter, and then one has to use the time domain implementation. But now with a many points on the filter, I switch for the frequency domain filter by clicking here. Then I get one more box here, and I click that and put 1 into that box. That is the first notch, and enter. And I want it at a position here, and that is something like maybe 100. This is not automated, so I have to check a little bit. No, 100 was there. So I make it 500. $700. $650 then. That's pretty close, and I have to make it a little bit wider. So I make the width, let's say 10. Not enough. So it's close, maybe 640 instead. And a little bit wider still, 60. Well, I make it 100. And then I have to remove the other carrier. It's here, and it is about. So I place first a 2 here to enable a second notch. Position minus 600 and width 100. And it was more like minus 700. Now you can hear the signal. And I have much more bandwidth than required. I have now applied a third notch for this carrier. So now it's a 30 Hz wide filter with 3 notches on it. And the keying is reasonably distinct. I can try to make the notches sharper by making a bigger FFT for this frequency domain filter. I do that by pressing this arrow here. That was because the recording now restarted from the beginning. Okay, so I click here. And it's still the same filter, but the notches are deeper, so I could make them a little bit smaller in width. This one is 70 now, so I make it instead, let's say 40. And it's still 70 decibels deep, but I should move it a little bit closer to the center. That means, let's say 645, maybe. 635 then. That looks fine, almost. And then I go for the second notch by pressing 2 here. And it's minus 720, and I think that's close, but I make it narrower. Let's say 30. And, well, 40. And then the third notch, 3. And 30. There is no AGC now, but it doesn't saturate. I can make this window a little bit smaller. Oh, and I lost the tuning then. Very slow now. I enable the AGC and now I can see here is the signal. So I click at that location here to bring the signal back to the right frequency. Here we are. I wanted to have the signal strength meter, the dB meter, and I want to run it a bit faster. Well, one more faster. And this was when the recording restarted. And now I can see the noise floor is at about here 10 decibels, and you can see easily PST. Maybe it's easier to see if I run it one step slower. And on top of this I can enable the coherent detection routine, the synchronous detection. This is an AM signal and here is the carrier. So I lock on that. Sorry, this box. Like this. And this is 100% copy, easily. And I have the AGC on, and that doesn't make much difference, but if I switch it off, so now I have demonstrated the notch filter in the baseband. I can draw the same graph with a different scale on the x-axis. I'm clicking here. And I can try to make the transform for the baseband that is used to compute this filter with a little bit more. It's now 15, that means 2 to power 15, 32,000 points. And now it's 64,000. And I could make the notches even narrower now, if I wanted. Here is now a 50 Hz wide filter on the PST and the two carriers. And of course we hear only the carriers, even though the PST is visible in the waterfall here. Now I will enable another function in Linrad, and that is the automatic spur cancellation. So I click here, and it says 100, and now it's up in 426, but you see the carriers are gone. And I can hear the PST reasonably well. Now there are instabilities in the carriers, so they give some signal now and then. We had something here. Here you can see. Probably the carrier of that station is a little bit chirpy when it's keyed on off. And here, when the recording started from scratch again, the notches didn't work for a while. And then it works again. And it now tells me 148 or 152 carriers are removed. There is a small white line for each one that is removed. And we are here now. So that's another feature of Linrad that sometimes can be useful. It's a little bit tricky to get the optimum out from it. I press P for parameters on the screen, and I have set a fairly narrow bandwidth for the first FFT, and I enabled the second one. And you can see hopefully all the parameters here. The next screen shows the second FFT, and I have set a high bandwidth reduction, so the FFT bandwidth is 0.3 Hertz. And then I have set AFC spur decode to 2, and the maximum number of spurs to cancel is 3000, and I have set this bandwidth, the spur time constant, to 5 seconds. That means 0.2 Hertz bandwidth for the notch. And these parameters are a bit critical, because if the carriers to remove are a little bit unstable, 0.2 Hertz is going to be too narrow. On the other hand, when there are carriers at a close spacing, it's necessary to have a fairly narrow filter, and also to have a narrow FFT bandwidth. So experiment with them if you're interested. It could be, well, I can look at the waterfall. It's now with this function enabled, and it takes some time before it starts working, but here it comes. 430 carriers removed, and we can see here in the NDB band a lot of carriers disappear. But some remain. Using the notch function in the baseband, that is safer, of course. There is a manual mode also for the spur elimination. The second FFT bin bandwidth is very small, so the scale is much wider here. So the strong carrier, this one, is this one. I place the mouse on it and press E for eliminate. And there it goes. And then I take the other one here and I press E on that. And then it's also gone. But they are not completely gone. There are some small reminders from them. Because of imperfections in the automatic spur removal routine. To set it in manual mode, X and P, and then here, spur the code to 1. I can press F1. And here you have the instructions for it. One thing to observe is that this manual mode for the spur removal requires Linrad 04.15 or some preliminary version of it you can find on the repo for Linrad, or some much older version of Linrad. For reason I don't remember, this manual version does not work in recent versions. You have to go back to fairly old ones or to the very latest. But the automatic is working on all versions as far as I know.